Hello everyone, our paper video presentation is on empowering end users to confine their own applications. This discussion will focus on the results of a usability study which compared three different confinement approaches using SELinux, AppArmor and FBAC-LSM. This presentation will be anchored by myself, I'm Rotimi, and my two other colleagues, Arvind and Manoj. So why do we need access control systems? Different operating systems use different security mechanisms to control or confine what individual users may do or may not do. Usually, whenever a process is executed by a specific user, that process inherits all the privileges of that user. So assuming a process is executed by a root user, this means that process will inherit all the privileges of that root user. This can pose a great challenge because if the application is a malicious one, the user won't be protected. This type of access control system does not protect users against malicious application and could leave the user and even the system vulnerable. So how do we prevent against this? We could use control schemes to prevent against this. One is the first one on the list called the application-oriented control scheme, which helps to restrict and control the actions of each application, and this invariably reduces the possible damage that can be caused by a malicious application. Examples are SELinux and AppArmor, which are already part of the usability study we'll be discussing about in this discussion. But this application-oriented control scheme are divided into two broad groups. The first one is the isolated base restriction. And what this does is to restrict application to a namespace and isolate them from the rest of the system. So try and imagine you had 5 applications. Each application is restricted to its own namespace. But the problem with this is, what happens when these applications need to communicate with one another, when they need to exchange data or resources with one another? So that's a snag on this. The other type of application-oriented control scheme is a rule-based restriction. This rule-based restriction employs what we call the least privilege concept, and this enables applications to interact with only resources they need to perform their legitimate task. This approach also comes with its own complexities, since different granular rules have to be created to grant access on a need-to-use basis. And as we can all see, the application control scheme, no matter which one is used, whether the isolated base restriction or the rule-based restriction, already poses some form of usability issues. It makes it difficult for end users to confine their own applications. So they decided to find a different approach and study the usability of both approaches. The other approach is what we call the functional-based application confinement approach, where applications are confined based on the functions they are meant to perform. The FBAC model is designed in such a way that the policy details are abstracted away from the users. The FBAC-LSM is an implementation model of FBAC. One more major difference between the two is the application-oriented control scheme uses the mandatory access control, while the functional-based approach uses both the mandatory and the discretionary access control. And the advantage of this is it allows both the administrator and the end user restrict applications in order to enforce their respective goals. The experimental objectives were clear, and it was to compare how usable the FBAC approach was against the widely deployed SELinux and the AppArmor approach. In total, there were 7 areas they wanted to compare or they wanted to look at, which are all listed here. And the first one, for instance, is user perception of the usability of the three confinement schemes. Another one is the ability to successfully restrict well-behaved programs and also malicious programs. The rest of the list are there, you can see them. Now the methodology or the method used. The methodology used for this experiment was to ensure that all participants used all three security mechanisms to confine two programs using policies. They had to construct policies to confine these programs. In order to carry out this usability study, they had to recruit participants, mainly those from IT background, that is IT students in university, information security association members, and even members of Linux user groups. After the recruitment was done, they had to prepare the environment that would be used for the experiment. And to do this, they set up 3 virtual machines, each one running one of the 3 security mechanisms. Because no single distribution supported all the 3 security mechanisms. And so, Fedora was used for SELinux, while OpenSUSE version 11.1 was used for AppArmor, and OpenSUSE version 10.3 was used for FBAC-LSM. Once the participants were recruited and the environment was prepared, the participants had to be prepped for the experiment itself, and this involved having them to watch an introductory video which explained the goal of the application confinement. That's the first thing. They also ensured that they filled a pre-experiment questionnaire to capture their demographic information, to rate their computer skills, get to know the level of their computer security and Linux knowledge, amongst other technical details. To again watch another video describing the way the security system worked. This was a detailed video describing policy components and how the components were stored on the disk, among other things. The participants were lastly notified that they had to fill a post-experiment questionnaire to capture their results and findings afterwards. My colleague Arvind will continue the presentation to this.
Thanks, Rotimi. I'm Arvind and I'll be discussing further topics of the paper. So the experiment was to confine the Opera web browser interacting with an untrusted host and simulation of a Trojan horse through a game called Tetris, which was downloaded from an unauthorized website. So the task given to the participants were to create security policies to restrict these programs to act maliciously. So let's see how security policies can be created using these security systems such as SELinux, AppArmor, and functional based access control. So let's see how we can set policies in SELinux. Through a tool called Policy Generator GUI tool, we can set policies in SELinux. This tool helps in specifying the executable paths, selecting ports and low-level application traits. In this picture, we can see that we can select some common application traits such as writing syslog messages, creating temporary files, etc. This creates an incomplete policy. So in order to have a complete policy, we run a number of command line tools. In this picture, we can see some command line tools running, such as allow write, allow read, etc. After specifying this command line tools, we run the confine program, which generates the detailed rules that authorizes the program to access the resources it requires to run. If we want to add any rules to the same program, we can rerun this command line tools in order to add any other rules for future purposes. Now let's see how we can specify application policies in AppArmor. In AppArmor, using the Yast AppArmor Add Profile Wizard GUI tool, we can specify application policies. The steps involved in specifying these policies are as follows. The user specifies the name of the application to be confined, and then the user is prompted to run the program. After we run the program, the users are asked to review and vet the program. Vetting is nothing but either allowing or denying each of the low level rules that would allow the program to behave in the same way in the future. Now let's see how we can create policies through a functional based access control mechanism. In functional based access control mechanism, a tool called policy manager GUI tool can be used to specify application policies. The steps involved in creating policies are as follows. First, the executable paths are specified. Then the type of the program, either the command line or the graphical line, is specified, which is typically suggested automatically and accurately by the tool itself. Then the tool performs some analysis and suggests likely high level functionalities and describes the feature the application performs. Then the user selects these functionalities to apply and takes the suggestions into the consideration. Trojan horse simulation. So for the purpose of the experiment, the Tetris game, which was downloaded from an unauthorized website, was modified to simulate a Trojan horse into the virtual machine. This modified program attempts to access many resources that the game should not need to. This Trojan horse simulation also attempts to access resources normally protected by discretionary access controls. The virtual machines were deliberately misconfigured to allow access to all these user privileges. This aspect of experimental design was to check the levels of security of the systems. Measuring perceived usability. The perceived system usability was measured using system usability scale, which is a widely employed and extensively verified tool. This system usability scale is a 10-item Likert scale, with even numbered items worded negatively and odd numbered items worded positively. So the participants were asked to give system usability scores to the systems on the basis of how easy they were to use, how easy they were to understand, and how likely they would use again in the future. Measuring policy quality and task success. This method is used to measure the quality of the policies created by the participants and the success rate of the task. The virtual machines from each participant were stored for subsequent data collection. The data collection involved testing the ability of the confined programs to run and the ability of the programs to access the security sensitive resources the Trojan horse attempted to use correctly. It also assessed whether the policies created were successful or not. The results showed whether the confined program was able to potentially act maliciously or not. We will discuss about this a little further. Pilot study. The pilot study was designed to eliminate potential biasing factors. For example, the order in which the participant used the systems was randomized. The names of the system studies were not advertised during the participant registration. The participants were not allowed to search the internet for information about the systems during the study. Now let's discuss the results of the experiment. Participant demographics. The participants' age were varied from 18 to 60. The participants were requested to evaluate themselves based on these objectives, such as their skills with computers, their knowledge of computer security, their frequency of Linux use with minimum of 1 and maximum of 7. This table shows that the majority of the participants evaluated themselves as possessing above average computer skills. System usability scale. As discussed, the participants were asked to give system usability scale scores to the systems SELinux, AppArmor and FBAC. So the results are as follows. FBAC received the highest system usability scores with a mean of 70.21 and standard deviation of 18.34, followed by AppArmor with a mean of 54.93 and standard deviation of 24.18. SELinux scored the lowest with a mean of 34.58 and standard deviation of 18.04. This shows that FBAC was easy to use, easy to understand, and it is more likely to be used in the future. Ranking. These security systems were ranked on the basis of ease of use, ease of understanding, and their likeliness of free use. From this table, we can see that FBAC has been ranked highest in all the aspects, whereas SELinux has been ranked the lowest. Creation of policies. From this table, we can see that in SELinux, total 31 policies were created for Opera and 9 policies were created for Tetris. But only 7 policies were enforced correctly in Opera and 2 policies were enforced correctly in Tetris. This shows that there was a success rate of 23% in creation of policies in Opera and 22% in Tetris game. When we come to FBAC, in 39 policies, total 35 policies were enforced correctly, and from 39 policies, 32 policies were enforced correctly, with success rate of 90% in Opera and 82% in Tetris. This shows that the policy creation rates in FBAC is comparatively more than the other two security systems, that is AppArmor and SELinux. Running of confined applications. This table shows the extent to which the confined programs can actually operate is affected by the security systems. Using FBAC, 97% of the policies created for Opera allowed the programs to run, compared to 56% and 43% for AppArmor and SELinux respectively. These results demonstrate that compared to AppArmor and SELinux, FBAC is more successful at not interfering with programs performing their legitimate functions. This table shows that 100% of FBAC policies for the Tetris game allowed the programs to run, as opposed to 70% of the AppArmor policies. My friend Manoj will discuss the further topics of the paper.
Hello everyone, my name is Manoj and I'm going to talk about risk analysis in performance evaluation. Risk exposure was measured using a simple score called demerit point. This measure was designed to give a clear indication of the effect of the security system on the exposure to threats by simply recording the number of realistic threats to the system. A post hoc analysis was conducted using the signed ranks test. Results indicate that SELinux is having more risk than the other two. FBAC-LSM was both the consistent and provided the greatest protection. Opera risk exposure. They conducted non-parametric Friedman test on the Opera risk exposure, analyzing the data from participants who created and enforced a policy for Opera using all the three systems. Results showed that AppArmor policies were slightly more restrictive than those created using FBAC-LSM. Trojan horse risk exposure. Friedman test was conducted to compare the effect of security system on the deserted risk exposure. Risk exposure was measured in the same way as previously, using one demerit point. For malicious programs, the results showed that FBAC-LSM will produce more secure confinement policies. AppArmor policies are often built by observing program behavior and having users review the rules generated from this. FBAC-LSM constructs policy based on the features the user wants the program to perform. Results indicate that users do not have enough expertise to vet the actions of programs as required by the AppArmor. The FBAC approach was found to be far more accessible by users with great protection, and SELinux would have rated even worse than AppArmor as there is no graphic tool to assist the users. Discussion. The results of the usability study showed that, compared to AppArmor and SELinux, FBAC-LSM was rated and ranked as easiest to use, and it had significantly higher rates of policy creation and enforcement, which had more policies that allowed the programs being confined to run and function correctly. To reduce the risk to the user, users reported preferring FBAC-LSM from a time efficiency point of view. However, AppArmor confinement procedures were sometimes recorded as taking less time, apparently due to users rapidly clicking through the dialog boxes without necessarily considering the message that was presented to them. These results will now be discussed in detail. Perceived usability. According to Banger et al., products with SUS results scores less than 50 should be significant concern and are judged to be unacceptable. SELinux scored 34.58, which suggests that SELinux suffers from major usability deficiencies and the lack of graphical interface. Products with scores less than 70 should be considered candidates for increasing scrutiny and continued improvement and should. The prime factor that limits AppArmor usability seems to be due to the inability of typical users making informed decisions about the files to which application requires access. This result showed that end users do not have the expertise to make low-level decisions about what access privileges their program require, and products which are at least passable have scores above 70. FBAC-LSM with a score of 70.21 was significantly preferred over AppArmor and SELinux. and there is clearly still room for improvement. It is a much newer and less mature implementation than the other two systems we studied. Continuing development on FBAC-LSM will further improve its usability. These results indicate that FBAC model in general is well suited to providing application-oriented controls capable of being managed by non-expert users. Rate of policy enforcement. The successful creation of a policy is affected by the difficulty of using the system and the difficulty in understanding how to create policies. FBAC-LSM again ranked highest in both the aspects, followed by AppArmor and then SELinux. In a SELinux policy generator tool, participants should run shell commands to recompile and load the policy. But participants forgot to manually set the policy to be enforced. It means that these policies were not enforced. Several participants reported that they were not comfortable to run console commands. A more complete graphical tool that helps users through the whole process would have improved success using SELinux. AppArmor's policy tools left policies either enforced or in complaining mode, which depending on users' choices. For example, exiting from the add profile wizard resulted in the policy left in complaining mode. FBAC-LSM created policies that were enforced by default, unless the user specifically toggled the policy activation. This combined with the wizard for creating policies that steps users through the process, and the fact that main window includes information about policy enforcement, appear to be factors contributing to high success rate in creating enforced policies. Confinement of trustworthy programs. FBAC-LSM was found to have no significant restriction advantages compared to AppArmor and SELinux. Further research is required for FBAC-LSM. SELinux makes decisions based on types assigned to files. In most cases, user applications will be granted access to excessive rights, that is, access to almost anything in user's home directory. This could be improved by creating more finely grained SELinux types as controls. The AppArmor policies created slightly tighter controls than those created using FBAC-LSM. AppArmor profiles stopped Opera from running at all, which significantly reduces their usefulness, therefore protection provided is lower. This analysis only considered policies that were successfully created and enforced, and FBAC-LSM had the highest rate of enforced policies. Confinement of malicious programs. Using this approach, protection from malicious programs is dependent upon users successfully vetting these rules. The results of the study demonstrated that typical users and even security professionals and Linux system administrators generally do not necessarily have the required expertise to successfully vet these actions. 74% of participants who created and enforced a policy using AppArmor allowed users to access the shadow file. A shadow file is a very high profile target that contains the hashed user passwords for the system. 71% granted write access to the host file, which could allow the program to redirect network traffic and perform man-in-the-middle attacks. 58% granted access to private information in the user's Firefox directory. However, many participants reported that the severity level metric was ambiguous and often absent. Others seemed to not pay any attention to the specifics of the rules at all, simply clicking allow to almost every rule. Therefore, the results of the study strongly indicate that ordinary users cannot reliably employ learning mode application-oriented access controls that rely on users vetting generated rules. SELinux does not currently have a graphical tool to step users through the vetting process. Alternate Fedora standard tools provided graphical tools to help users through some of the process. FBAC-LSM sustainably lowered the risk exposure compared to AppArmor. Therefore, FBAC-LSM clearly provided the best protection of the system studied. If the program is malicious, it could compromise the system while a policy is developed. The FBAC-LSM implementation is relatively new compared with the other two schemes and occasionally caused crashes, requiring the VM to be restarted again. A SELinux policy conflict which excluded some results from a large number of participants from analysis. Conclusion: SELinux provides a mature and technically robust framework. However, Due to its complex model and pure usability of its existing tools, the study showed that it is having a low success rate. In contrast, AppArmor is relatively easy to learn. However, the security decisions made during policy construction still require expertise that end users are unlikely to have. The study demonstrated that the FBAC model can be effectively employed by end users with limited technical expertise to protect themselves against both vulnerabilities and potentially malicious programs. Thank you.